Thank you, and thank you very much for coming to this session. And yeah, I know that now it's time for a siesta, so please don't get asleep. Let's see some demos. If they work, because now I'm starting my cluster in my computer, it seems that they are taking more time than expected, so yeah, let's see what's happening. My name is Alex Soto, working in Red Hat. I'm the creator of a lot of the jars, and yeah, you can find me in several magazines and so on. And also, if you are in the Java ecosystem and you're interested in this logo of Duke as Gandalf, I have some stickers here, so after the session you can grab it some if you want. One of the important things is that there is a raffle today. Here I'm just, if you follow me on Twitter with a picture of the session, mentioning me and with the hashtag JOTB19, I am just raffling 2 electronic books of this book, Testing Java Microservices, which is I'm a co-author. But also, after this session, I'll be out of the hall, which there are 20 books that are free to take it if I sign them. So if you are interested in testing Java microservices, we see after the session and the hall. So a long time ago, now it seems years, but it was not so many years, we had something like this, right? It was like a monolith application with, my application there running. In fact, it was not that. It was something like this, a monolith with several modules inside this monolith application. And inside every module, even we can have more and more modules. But then 2 years ago, we thought that it would be a good idea to start breaking this monolith, and we start breaking them and connecting all of them in a service mesh between a network. As you can see, this is a mesh because it's not a tree structure, it's a graph structure when you see that all the services can call each other, and everything happens across the network. And you think that this is quite interesting things from the point of view of infrastructure. Also, each service has its own databases, and even each service might have an entry point from outside world. And probably because of this, it's really interesting to have in front of a microservices architecture an API gateway. But at the end, if you think about microservices, we are talking about distributed computing. A service which calls using network another service, which at the same time calls another service, and then get it a response. So if you are in the Java world, you have the service, you have the JVM running this service, and then you have the operating system. The problem is that as developers, we think that this structure is like a memory call. When we call from service A to service B, it's exactly the same thing that we were doing when we had a monolith. In the monolith, it's a memory call, right? All the methods are, grabbed from the stack, from the memory, and in the microservices, you're using network. And we think that, well, at the end, it's exactly the same. The problem is that it's not like that. There are some fallacies of distributed computing. The first one is that the network is reliable. We are assuming that network is always there. We assume that the latency is 0, that we can do a request, and immediately we will get a request. We think that the bandwidth is infinite. We can send whatever we want, gigabytes, to the network. Network is supported. The network is secure. Nobody can break our network, right? The topology does not change. There is one administrator. Transport cost is 0. The network is homogeneous, right? This is all the things that we think as developers, that it's a network. The problem is that, first of all, it's not like that. And the second is that what happened during a network outage? What happened when the application tried to reach another service and the service is not responding? Probably we are just looping there, waiting infinitely until this service gets up and running. But it's even more. It's what's happened now when there is a service that is failing in the middle of the mesh. What's happening now? Well, it's not only this service is failing. It's failing all these other services. There is all the transitive dependencies of this service are failing as well. So now, an error that happens in one place, it's propagated across all the mesh. So as you can see, done properly, network is an error card. Done properly, right? So it's not easy at all to do it. The good thing is that microservices implement some kind of things that I like to call it cross-cutting concerns, which are these ones. That helps to us to implement microservices correctly in the network. And basically, you have your service with your business logic that can be written with any language. And then we have an API to reach this service. A discovery, we need to find a way to discover this service. An invocation, how we invoke services. Elasticity, what's happened when I have a high load traffic, then I need to scale up automatically. And when you have less traffic, then I need to scale down. Resilience, what's happened when the service goes down? It's failing, what I need to do. Pipeline, I need to be able to deploy my services automatically. Authentication, this is really interesting, right? Because with monolith, we are just adding a front layer of security. But what's happened now with microservices? Do we want to secure service-to-service communication or just the front layer? Logging with monolith is really easy. We have a file with all the log lines there. But now, log is spread across all the mesh. So we need to find a way to correlate all the events. Monitoring, really important to know what's happening with the services. And finally, tracing, what's happening inside my mesh. Given a request, I need to know exactly what's happening inside the mesh with this request. So you might say that it's really complex, and I want to do microservices, but now, because of microservices, I am adding all these aspects that I need to take care. The truth is that if you are following or you are implementing your microservices and deploying in Kubernetes or OpenShift, OpenShift is the Kubernetes for enterprises, I mean that it's just a Kubernetes, then you are fixing most of the things. For example, in case of discovery with Kubernetes, it's the concept of service. With Kubernetes, we have a service, and you can think about a service as a load balancer, right? That we just redirect the traffic to the real machine. The invocation, elasticity, it's the concept of replicas, where you have a pod and you can say, I want 3 replicas. Or you can even do some kind of automatic monitoring and say, OK, now I want to increase the replicas. This is how elasticity works with Kubernetes. And even if you are using OpenShift, you get it, the pipeline, the logging, and the monitoring concerns also cover it. The problem is that there are other places. For example, resilience is not covered. It's not covered also, for example, tracing. So usually what you end up is that your service is something like that. You have a container because you're running inside Kubernetes. You have your JVM. You have all the services. And inside your code, you start adding some of these cross-cutting concerns implemented inside. For example, discovery, load balancer, resiliency, metrics, and tracing are usually things that you put inside your code. If you are into Java ecosystem and you are implementing microservices, probably all of you knows histories. And you say, yeah, I'm just using histories, I put it in the class path, and then I annotate something, and it just works. And that's true. But notice that you are adding some complexity inside your business code. So how about if I told you that I could take all these cross-cutting concerns and add it at infrastructure layer? I don't want to put things that has appeared because of microservices. Notice that all these cross-cutting concerns are there because of microservices, because of the network. Why I need to put these network problems inside my code? It's an infrastructure problem, not my problem. So could I make it better? Could I put all these cross-cutting concerns inside the network? But first of all, before getting you the answer, I want to introduce you one interesting concept, which is pods. Everyone knows here what is a pod, probably. But what usually people don't know is that a pod is a group of whales. I mean that in the nature, when you say that a pod, you're referring to a group of whales. And if you know Docker, the logo of Docker is a whale. So Kubernetes guys decided that it would be interesting to have a pod as a name. The thing of a pod is that usually people use one pod, one container. But that's not true, because remember that the pod is a group of whales. So it means that inside a pod, you can put more than one container at the same time, sharing the same IP, sharing the same data. volume, and of course sharing the same life cycle. And this is where Istio comes. Istio is a service mesh. And a service mesh is a dedicated infrastructure layer for making communication between service secure, fast, and reliable. And this is exactly what does Istio. But if you want to go inside Istio, you need to change that. You need to think about that you're going to change how you develop, how you deploy, and how you release your applications. Because now we are moving all these pieces of code to another place. So with Istio, we are having something like this. There are some overlappings, but we are covering everything, all the cross-cutting concerns. So notice that if you are using just Kubernetes and Istio, and probably also OpenShift, then all this logic goes inside infrastructure layer and not inside your code. So with Istio, you're doing something like this. I've got my service, the JVM, the container, the pod, and then inside the pod, there are running two containers, the service container and a sidecar container. This sidecar container is, in fact, an Envoy proxy. An Envoy proxy is like HCI proxy or Nginx. It's a proxy which allows you to intercept traffic and manipulate it. In case of Istio, what it's doing is just intercepting all the traffic that goes out from service A. This traffic goes through the sidecar container, so the Envoy proxy, and then it manipulates this traffic. Manipulates the traffic, and then it sends not directly to service B, but to the Envoy proxy related to service B. Then this Envoy proxy receives the request and said, OK, I can manipulate, and then send it to service B. And the same for service C. And the response, it does exactly the same path. Goes through the Envoy proxy to the other Envoy proxy and to the service A. So now there is no direct connection. There's always traffic through Envoy proxy. In this way, we are able to make things really interesting with this traffic. Some Istio concepts. The first one is a destination rule. Destination rule is a Kubernetes custom resource which allows you to define circuit breakers, load balancers, TLS settings, or even defining subsets. Defining subsets is like creating groups of services. Then we have virtual services, which is like, it's virtual. I mean, it's not the concept of service that we have in Kubernetes. So it's not a registry, and just describe the mapping between destinations. So this is where we define that service A can communicate with service B version 1, and maybe service A version 2 needs to communicate with service B version 2. Then we have service entry, which is the one that allows you to configure traffic to external services. By default, with Istio 1.1, all traffic is able to reach anything outside the mesh, but in Istio 1.0, this was not the case. Any traffic that goes outside the mesh should be set. And now with Istio 1.1, you can do another, the reverse thing. But it's like saying that you don't allow traffic go outside the mesh. And then we have the gateway, like it's a load balancer that it's at the edge of the mesh, which is to get traffic inside the mesh. So things that you can do with Istio. The first thing is traffic or manipulating the traffic and saying things like, I want to send traffic from service A to service V, or I want to send 90% of the traffic to service A version 1 and 10% of traffic to service V version 2. Of course, you can do one thing that is called mirroring traffic. So you can just send a request to two services at the same time. Or you can do one thing that's called dark canaries, which basically it's like canary releases, but instead of sending percentage of traffic, what you're saying is, or you're sending is things like, if the traffic comes from a mobile, I send it to this service. If it comes from Safari, then I send it to this other service. And if it comes from Chrome, it sends to this other service. Or, for example, things like, if the request comes from this range of IPs, then it goes to this service. But if not, it goes to another service. These are things that you can do with Istio. It implements also circuit breaker. Again, if you are into into microservices, you already know what is circuit breaker. And one of the great things about Istio, what our Istio is doing, is implementing the concept of pool ejection. This is something that does not exist with any circuit breaker solution. And pool ejection is basically doing the next thing, is that in Kubernetes, probably you have one service deployed, so it's one pod, and this pod is replicated 3 times or 4 times, right? So you have 4 instances of the same service. What's happening if one of these services is failing? Usually it's failing because it's getting a lot of traffic. So what you want is to stop sending traffic to this pod. So what Istio does is just takes this pod out of this pool of pods. So you have a pool with 4 pods. If one pod is failing, this pod gets out from this pool. So now all the requests just get the running pods. And this pod will not receive any more traffic for an amount of time. And this is a really good strategy because then this traffic that it will not receive more requests will have able time to recover. Maybe recovering because it has a lot of work to be done and the work is done. Or maybe Kubernetes minion will decide that it's time to kill this pod and create a new one. So from one point or another, what you are doing is just taking out this pod from eligible list of pods, which protects you from other future errors. Since we are manipulating traffic, we can do one thing that is called chaos engineering or chaos testing, something that probably most of you knows because of Netflix, and maybe some of you are just doing chaos engineering because testing is doing it. And I'd like to share you a really good experience. I was talking, I think that it was like 6 months ago with a company, and I said, we are doing chaos engineering. Oh, yeah, really? Yeah, we're doing chaos engineering. Oh, that's great. Yeah. And I asked them how it went. I said, well, it was a totally disaster. Oh, really? Yeah. And why? Well, you know what's happened? That we tried as a first experiment to kill all our production cluster. Oh, yeah? And what happened? And they said, no clients could access to our application. And it was us, really? I didn't know that if you kill all your cluster, you can reach to the cluster. Yeah, of course, right? It seems stupid, but this thing happens. And this happens because simply we do things because Netflix is doing these things. And in case of chaos engineering, it's really easy to do it with Istio, but you need to first learn how to do it. And even more important is notify to the monitoring team that you're going to do it. Because if not, monitoring team is going to start watching that a lot of services are dying automatically without any reason, and it's because you are doing some kind of chaos engineering. So first thing is learn how to do it. Second thing, notify all the company that you're going to do it. And one of the things that all our clients in Red Hat finds really useful Istio is security. If you're in Java and you are securing your services and you start working with HTTPS, you know that it's really painful, right? You have the CAs, the certificates are revoked, are refreshed, and well, it's always a pain. With Istio, you just forget about all this stuff. You as a developer work with HTTP, period. Then you configure Istio to do the point-to-point communication with HTTPS. Then what's happening is like, I'm working with HTTP, I send my traffic through Envoy, Envoy converts my traffic to HTTPS, it sends to the other service using HTTPS, this HTTPS data arrives to the other Envoy proxy, this other Envoy proxy transforms HTTPS to HTTP and send back to the other service. So you as a developer always work with HTTP, and the infrastructure works in HTTPS. But it's even more, is that Istio is able to create a CA and populate all the certificates across all the mesh, and even revoke certificates, refresh the certificates, create new certificates, everything automatically. So you do not need to take care of anything. This is for MTLS, but also, since security is really important with with Istio, you can create black and white lists. So you can set service A can only communicate with service B, but not with service C. So if an attacker gets control of your service A and tries to reach service C, it won't be able to do it, because Istio is protecting this communication. And finally, also it implements a really airbag system with JWT. So you're sending a BRE token, which should be a JWT token, and then Istio is going to validate with the public key that this token is valid, that has been signed and not modified, verifies that has not been expired, and then if you're setting that service V requires a role to reach, it checks if the token contains this role. If the role is inside the token, then it lets the communication go through the service, but if not, it just sends a refuse because there is a authentication problem. So as you can see, everything is managed automatically by the infrastructure layer. You as a developer, you don't need to take care of validating JWT tokens, HTTPS, or checking how to route the problems. Also, it implements observability. Observability means that you know exactly all the time what's happening inside the mesh. By default, if you do nothing, Istio comes with Prometheus for monitoring, Grafana to visualize all the monitor things, and with Jigger to trace what's happening inside your mesh. And now let's see a demo. Let's see if it works. Wait, I don't know where it is. I don't know if it works or not. Yeah, it didn't work. Error, timeout. Let's start again. Meanwhile, at the starts, there is any question? No questions? Yeah. I cannot see anything. Wait, there, yeah. Yeah.
Hello.
Yep.
Hi. It's Jose from Oracle.
Yep.
So it's a question regarding security. You mentioned that you are validating JSON Web Tokens, right? Are you following any protocol like OAuth 2.0?
Yeah, with it's OpenID.
OpenID Connect.
Yeah, so you are just defining in your Istio resource. You're setting the OpenID. It's in this location, and then it takes everything from there. Even it's I mean that you can do it in this way, but I have some demos, and in these demos I just put a GWKS file, and then I just point out to this URL. So I mean that you don't need, if you want to start playing with it, you don't need to install any OpenID service like Keycloud. You just can point to the GWKS file, and that's all.
Okay, thank you.
You're welcome.
Hi, it's Frank from Apple. So what PKI are you using for MTLS?
For MTLS, yeah, by default, I don't know. I mean that you can set all this infrastructure by yourself. I mean that all these files and everything by yourself. But by default, I don't know it. I know that they provide, but at the end, usually these default ones are just for demo purposes, right? Because you would like to use your own certificates. Notice that this is for internal traffic, not external traffic. But what comes by default, I don't know.
Do you know if it has any capability to switchover connections when, let's say, short-lived certificates are rotated out?
Yeah, but in fact, by default, I mean that Istio takes care of this. I mean that you can create short life certificates and they will replace them automatically. You don't need to do anything. So you can put, like, for example, 1 minute, and every minute, Istio will spread new certificates to all the mesh. Well, to all Envoy proxies, in fact.
Thank you.
Oh, oh man. This is not going to work. Let's wait for some minutes, and if not, I will just, but it's, because I don't know if there is, okay, I'm going to start showing you how files look like. The first thing is, remember that I said a destination rule. Wait, I'm going to put it bigger. This is how you define. This is how you define subset of services. So in this case, I'm just saying that I have a recommendation service with version v1 and version v2. So I'm just registering there the services. Then, let's see, this is still there. What's happened, for example, let me, because I don't know why. It seems that there is no Wi-Fi, and this makes everything stop working. Okay, then, what's happening if I want to send all traffic to service B1? I just need to go to virtual service, recommendation v1. So what I'm saying here is like, when I have an incoming request to recommendation service, then send the traffic to version v1. And I want to send all the traffic, just 100% of the traffic to v1. If then I want to do, for example, a blue-green deployment, which is like I change from v1 to v2, the only thing that I need to do is just virtual files and do this one. Which, as you can see, I'm just saying, now I want to send all the traffic to version v2. So I just need to apply this resource, this custom resource. Notice that it's a Kubernetes custom resource. I apply this, and then all the subsequent requests will go to this new service. And this is not working because I think that it's because there is no Wi-Fi. We can try to do this. Let me try. No.
There was a problem with the internet connection. The other room, maybe you can hotspot for a moment.
But I don't know how to, yeah. Well, let's continue and let's see if the Wi-Fi is fixed by the end of the session. Then, You just apply these resources, and then things goes from a version v1 to version v2. What's happening, for example, if I want to do a mirroring traffic, which is like, I have two services, service A v1, service A v2, and I want to send the request to both of the services. So this is mirroring traffic. It's sending a request to two services, but the response only comes from one service. So the other service, its response is just forget it. It's like what it's called find and forget request. So you have service v1, service v2, send a request, service v1 returns a response, but service v2 just gets a request, but it doesn't make anything with the response. And this is really useful if you want to do some kind of testing in production. If you want to do testing in production, then you can deploy your new version of the service, then do a mirroring traffic between the old version and the new version. Then the request goes to the old and to the new. The response that will receive your client will be the one from the old version, but the new version will also receive the request. And this allows you to start monitoring this new service and see what's happening with it. If it works, if not, if it has some performance problems, and all these kind of things. If you want to see how you can do this, it's like this, which is really easy. Again, you just need to create a Kubernetes resource where you say, I had version v1, which is the default one, but I want to mirror to version v2. So if you do this, automatically the request will be duplicated to v1 and to v2. What else we can do is, for example, as I said before, do a dark canaries. So I want to send traffic depending on, for example, the browser. To do that, I just need to do Istio files, virtual service. For example, Firefox, it's OK. And in this case, what I'm saying is like, if there is a header with user agent containing Firefox, so I'm just putting I'm just inspecting the header value, then send it to version v2. But if not, I can send it to version v1. This is like the default option. Notice that this is a special case with the user agent, so it's for browser, but you could even create here your own custom headers. So if you want to run some kind of test on your production environment, but you don't want that public transport reaches this new service, you can create your custom header called test traffic or something like that, and then you can just redirect traffic depending on this header. So you say, if there is a header called test traffic, then send it to v2. If not, go to v1. So you can start testing on your own application on the public or your production cluster. So you don't need any pre-production or staging cluster. OK. Now, let's see if we've been lucky. No. OK. Let's try it by the end. So if you want to learn more about Istio, there is this tutorial. It's an Istio tutorial, which it's really extensive. You can see simple things and advanced topics, like, for example, MTLS, GWT, future graduation. There is also a cheat sheet that I created. So if when you are used with Istio, you can just download this 4-page cheat sheet, so you have everything there. And I couldn't show you, but as I said, Istio by default comes with Grafana and Prometheus. So by default, it's just taking all your traffic and send it to Prometheus, and you can check the global success rate or the success rate by service and so on. And you don't need to install anything. It just works. Also, it comes with Jigger. Jigger is for trace. As you can see here, I've got a service called customer, see here that it's a customer preference recommendation. So these 3 services. And if I want to know what is happening with this request, I can see it here. I see that the request in total takes like 9 milliseconds, which spends 6 milliseconds in a customer, then 4, this is the, the correlate. So you can see exactly what's happening. When you click here, you see all the information of this request. So without doing anything, in the past, if you are using Jigger, you need to install Jigger. That you need to configure Jigger inside the service and so on. But with Istio, it's done automatically. And finally, this is something that comes also with Istio 1.1, which is Kiali. Kiali is a open source project sponsored by Red Hat, which just creates, an overview of all your mesh. So you see that here that I've got a product page v1 that goes to details v1, and then we have here ratings, which have v1, v2, and v3, and well, you can see everything. And even you can see the live traffic. There is an option, you said, I want to see live traffic, and you're just going to see some bullets moving around, and it's all the traffic, that is how it's happening. And it's really easy to detect if it's something it's failure, because it's like green arrow, it's that everything is okay, red, something is wrong, and you can click to the arrow, and you can see everything. And even in the latest version of Kiali, you can even start creating rules here in Kiali. So instead of applying resources manually, you just can go to product page and say, okay, I want to send everything to V2. And you do this from Kiali. You don't need to create any resource file. You just go here, apply it, and you see how everything behaves. Of course, Istio is not perfect. For example, the case of circuit breaker, it's a bit more powerful, for example, the case of Istrix, because you have this bulk ahead and all these fallbacks. So there are some people that start mixing concepts in Istio and concepts in the code. My suggestion is that don't do that if you don't really need it. Because then you're going to have everything spread everywhere. And it's really hard then to find out where things are happening. So my suggestion is that don't do that. Put everything inside Istio. And if you are really sure that you need to put it in the code, then put it in the code. Of course, this was like 2018, right? And we have Spring Boot or Go or Quarkus or whatever, and then we've got it Vertex, and then we've got it Netflix Eureka for service discovery. We've got Open Tracing, Kubernetes, Istrix, Zool, Ribbon. We've got all this kind of stuff inside our code. And notice that this means that you need to maintain all these libraries in all the services. But now with Istio, almost everything goes out. So you just Istio and just Istio in Kubernetes, and you just need to focus on the technology and your code. Also, some people said, it's really nice, this kind of Istio. I'm going to, after the session, I'm going to start doing it. And it's, at the same time, it's dangerous, right? Because it's, as you can see, you just apply a resource and you change how your application is behaving. So, first of all, you need to identify in which place of this Darwinism, I just call it digital Darwinism, you are. If you're not into DevOps, then don't start using Istio. If you are into DevOps, then are you using self-service on-demand elastic infrastructure as code? And and this is something really easy to check it out. When you need for example, you're using PostgreSQL, and you need a PostgreSQL in a production-like environment, and you need, as a developer, to do some tests, how much time it takes? 1 week, 2 weeks, or 5 minutes? If it takes 5 minutes, then you're in this. If it takes 1 hour, 2 hours, 1 week, then you know that you have not been meeting this. Automation, everything with Puppet Chef and Ansible Kubernetes, having CI/CD. Then when you have got CI/CD and everything is automatic, there is no manual steps, you're going to start adding Istio and start doing this kind of advanced deployment techniques like canary releases, blue-green deployments, dark launches, dark canaries, all these concepts, and then you can start moving to real microservices architecture. I think that Istio is really an interesting technology. It changed how we develop, how we deploy, but also how we release. Because now, with Istio, we can do all these magic things really easy. You can just send traffic to one service or another depending on the header or depending on the weight of the traffic or whatever. And it's really easy, right? So it's really interesting technology. And that's all. I mean, just to say that now we've covered like only the pure microservices, but there is also serverless. And if you are thinking about serverless, probably it comes to your mind Knative. And for now, Knative also relays on Istio. So when you are using Knative, you are using Istio. And that's all. Of course, if there is any question, you can just read me in Twitter or blog. And of course, there is also the email. And some people ask me, but can I send you an email? And it's, yes, of course you can, because I put it here. If not, the mail will be not here, right? So yeah, you can send me an email as well. Just before, let's say now, if, oh no, maybe it works. Let's see. Yeah. We are almost there. Yeah. We'll be able to see some demo. Delete pod. Oh, this is a really nice trick to just refresh all the cluster. I'm just deleting all the pods, but not the deployment. And since the deployment is the responsible of checking the life cycle of my pods, then they just restart all of them. It's you know. So now I can let me see login. Yeah. And then I can also go here and do. I don't know if you know K9S. I don't know if you know it, but K9S is this one, so I can see my state of the cluster in a better way than just having to type all the time kubectl, kubectl, kubectl. So now I've got 3 pods. Customer, preference, and recommendation B1 and recommendation B2. So basically what I'm doing is just customer calls preference, and preference calls recommendation B1 or B2. So I'm going to do a call. And you see that I'm getting B1, B2, B1, B2. Right? This is because by default, if there is no rule, Istio just do a round robin approach. So first B1 and then B2, then B1 and then B2. Now let's start applying some interesting things. As I said before, you need to apply one destination rule, which is like registering that there is B1 and B2. Again, if I do call now, it's exactly the same. Wait, let me check if I can move this. Okay, now it's much better. So I'm just getting B1, B2. Now I want to send all the traffic to B1. Okay, that's really easy. I can just do a create -f, Istio files, visual service, B1. And now if I do call, I'm just getting all the time B1. If I want to do the same, but into V2, I can just do replace Istio files, visual service B2. So now I do a call, and I'm getting B2 all the time. So it's really fast to do, right? I just apply one resource or apply another resource, and all the traffic is verified. Now it works pretty fast because all the cluster is on my machine. If you're in a real cluster, then it depends on how much time Istio takes to send all the requests to all the envoys. So if your envoys are in the same cluster, then it's fast. If your cluster is spread across the globe, then it will take maybe 30 seconds. But, I mean, it's pretty fast. Let me show now how you can implement mirroring traffic. If you see here, you're seeing all these numbers. You see that it's like 4, 5, 6, 7. This is just it's just a counter, right? For every request that you're receiving, it's a counter that's incremented. Now, I'm going to apply replace Istio files, bureau service, mirror. So, see V2 is really important. This. Remember, V2 is the number 7. So it means that when I receive another request to V2, this number will be incremented. If you want to see it better way, I can go here. And by the way, see that this is inside a recommendation pod, and notice that there is 2 containers running. Recommendation, which is the service, and the Istio proxy, which is the Envoy proxy. For this reason, I said that now a pod contains 2 containers and not just 1. Now this is the logs. You see that the last one is the 7. So now I'm here doing the mirroring, and I do a call. Now I'm getting V1, and the number is 8, and then I do a call, and I'm receiving V1, the number is 9. Now if I check here, you can see that the V2 is also 9. Right? So I left it in 7. The user didn't receive any response from V2, but the request reached V2. So this is how you can start testing this service before serving the traffic to the public. We can even do, and the last thing, I would like to show more, but maybe we will not have time. So I'm going to clean all the rules, so now everything is at the initial state. -f. Okay. And now I'm just going to scale up. Still scale V2 to 2 replicas. Notice that it works really, really, the scalation, well, it has been scaled, yeah. Then I can ask, and notice that this is starting really fast. This is because all these services runs with Quarkus. I don't know if you know what is Quarkus. This is the new toy there that is sponsored by Red Hat for creating cloud-native applications and using Graal VM. Then I have 2 instances, recommendation V2 and recommendation V2. There is 2 instances of the same pod. Now I can go inside which pod? This one, for example. Again, there is 2 containers. I'm going inside the container. This is inside the V2, and I'm going to do a call. Before that, I'm going to do call so you can see what's happening now. Notice that now what's happening is that I'm receiving V1, V2, V2, V1, V2, V2, right? Because there is 2 V2 instances and it's a round robin. And notice that the important one is this one, which has the number 2, which is the one that is 7RQ4J. This is really important pod now, okay? This is important. Why? Because this is inside this pod, and I'm going to do a call localhost 8080 misbehave. And notice that now I'm saying here that this service now it's returning 503. So basically what I'm doing is just fixing an error. So now there is one pod, one instance of this pod that it's always behaving incorrectly. So it's just returning 503. So you know what's happened now when I do a call? Any bet? I will receive a 503 here? Probably not. But you don't know why? Yeah. Exactly. Because by default, Istio 1.1 has an automatic retrace with pull ejection. So what's going to happen now? I do a call, and I'm getting B2, but notice that this the old one. It's not the 7, it's not this one. It's not this one, the 7R, but the old one. Now if I do another call, I got V2, but it's the old one. And I do call, I do V1, and then V2, and then V1, and then V2. But you never get it an error. But you even not get any response from this misbehaving pod. And I finish right now, because now if I do a call localhost 8080 behave, now it's just returning everything to 200, and if I start doing calls again, you can see that the old V2, the V2 that was misbehaving, it's now back and running again. And that's all. Thank you very much for coming. And remember, I will be now out. If you want testing Java Microservices book, there is 20. The first, the first to come, first to serve, and I will send it. Thank you.
Okay, there are a couple of questions, but we have time only for 2, so feel free to reach him out during the break.
Yeah.
The first one is, are there any good practices, rules, or guidelines compilation on how to integrate meshes and sidecar deployments in a development workflow in such a way that they don't become a mess to maintain?
Well, the quick answer is that when you want to deploy a service with Istio, you are just using istioctl kubeinject command, and this is automatically created by you. You don't need to deal with this sidecar container. It's automatically done. You don't need to do anything manually.
Okay, and the second question is about the Istio and Hasselcast integration.
I think that there is no, I mean that you can integrate it, because I did it with Redis. You need to configure to use probably TCP if it's using the binary protocol, and that's all. But it works.
Okay, and the rest of the questions, please feel free to reach him out, and let's give him another round of applause.